Hi guys, welcome back to my channel. So in today's video, we'll be discussing about version control systems, and we'll also be looking into what are the different types of version control systems. Then we will be talking about Git and GitHub. We'll be looking into the installation of Git on Linux system, and also we'll be looking into some commands that are used for Git and for the collaboration and maintenance of the repository by the teams and developers. So without any further ado, let's get started. Let's look into what are we going to discuss today. So we are going to look into what is a version control system, what is the difference between centralized version control systems and distributed version control system. Then we are going to look into GitHub. Then we are going to look into the Git installation on Unix. And then we are going to look into the Git commands that are being commonly used by developers as well as a lot of DevOps engineers. We can also discuss about the branching strategies that are being used by DevOps engineers, and it's a very popular DevOps engineers interview question where they ask about Git branching strategies that could be used. So let's start with what is version control system. So version control system is basically a source code management tool or a software systems which basically help the developers and the DevOps engineers to better track the code changes as well as uh, for better management and collaboration. And there are certain advantages of using version control system. So when an organization basically starts developing the code and the code base grows, it becomes really difficult to track those code changes that are happening. And since many developers are working on the same piece of code, so there is a possibility that there could be an overlap on the module that is being developed, or let's say there is a Java class on which two developers are working simultaneously. So how do we track the changes? What branches should be created in order to make sure that once the first developer checks in the code, the second developer will either take an update of that particular code and then merge his or her code. So we are going to look into all those things today, like how does different git merge and different git strategies work. Some of the reasons why version control systems is beneficial is repository. So it provides a repository to be maintained, and this repository is where you maintain your code base. So your organization's code base or your project's code base can be maintained on this version control system. So once the repository is being created and maintained by a user, then it is being, or let's say by an admin in an organization, then developers can start taking the code in their local. They can start checking out the code in their local, and they can start working on the repository which is present on the local. So some other features which are common in VCS or version control systems are check-in, commit, and checkout. So checkout basically means that you can check out the latest code from the main branch or the master branch into your local repository, and then you can start creating. You can start working on that particular code, or you can create your own branch. Let's say you create another branch, dev branch, and you start working on that particular code. And once you start working on that particular code and you have made your code changes as a developer, then you can commit those code changes. And mostly the code changes are committed with a message, and that message has a significance. It lets other developers know whenever they are checking the repository that why this particular code change was being made, what was the purpose of this particular commit that was made by a developer. Then the next reason why why we are supposed to use, or why VCS is being used so much by different organizations, is versioning. It helps in maintaining the versions of the code. So let's say once your code has gone to production, so there is one version of the code which has already been released to production, and now the developers have started working on another sprint and they are working on another piece of code which will be moved to production. So you can version your code, and you can know that if one point, if a certain code is being checked in, then the next version of the code could also be checked in. Then branching and merging. So basically you can create your own branch in your local, and then you can push the relevant changes and commit the relevant changes. So once you commit the changes, you can push the branch that you have created to the branch that already exists on your repository. Let's say you have created a branch and you have named it as dev, then you can push it to the master branch, and you can request for a merging of this particular code that you have created. And once this request it reaches to your GitHub repository, then over there you will have some admin or your system architects who will look into the code changes that you have made, and then they will either review your code, and they will give some comments, or they will say that this code is okay, and they will allow you to merge your branch or your code, and they will provide the approval for the code that you have checked in. Then comes collaboration. So using VCS or version control system makes it easy to collaborate with other developers also. So let's say one developer has made any changes, then other developer can go and look into that particular changes, and then accordingly the other developer can start working. Similarly, if a code change or a commit is being done by a developer, an architect or a senior member of the team can review the code. So that is where the collaboration comes into the picture. So collaboration becomes easy when you are using version control systems. Then tagging and release management, so it is also very helpful during the release management. So you can create tags, and you can make sure that the correct tags are being released during a production release, or any other kind of releases. Then it also helps in maintaining a change history. Now let's look into the difference between centralized version control systems and distributed version control systems. So centralized version control systems, the example could be your SVN, which is Apache Subversion, or Tortoise. SVN is something that is a part of your centralized version control system. And then we have distributed version control systems. So Git is an example of distributed version control system. And what is the difference between both of these, centralized version control system and distributed version control system is? So basically, distributed version control system is a type of version control system in which each developer has a complete copy of the project's repository, including the entire version history on their local machine. This is in contrast to centralized version control system, where there is a single central repository that developers interact with. So in case of distributed version control system, the developers will have local copy on their machine. They will have a local copy on the machine, whereas in the case of centralized version control system, there is a single central repository that developers have to directly interact with. Also in DVCS, developers can work independently, make changes, they can create their own branches, and even commit changes locally without needing a continuous network connection. They can later synchronize their work with other developers of the central repository when they have an internet connection. The distributed approach offers several advantages, such as increased flexibility, better support for branching and merging, and improved collaboration in decentralized manner. And Git is an example of distributed version control system. Now let's look into the installation of Git on Ubuntu, and we'll be installing Git on our Ubuntu machine. So without any further ado, let's get started with the installation. So we will quickly spin up an Ubuntu machine on our AWS console. So we will go to EC2, we will go to instances. So as of now, there's no machine, so we will quickly launch an Ubuntu instance. So before that, I wanted to show you that this is my GitHub repository. You can go and follow me. I keep updating my repository. I keep adding more and more relevant content to the repository. And this is the repository that we are going to follow today. So this is the code, the README code that we are going to follow today. You can also follow along with this code. So we are going to install and configure Git on Ubuntu. So let's get started. Let's launch an instance. So let's name this server as Git server. Let's select an Ubuntu machine. Let's select an instance type. So I think T2 micro will be sufficient, and it is free tier eligible. So whatever we are doing today will be free tier eligible. And let's create a new key pair so that we can SSH it. Although we will not be using it, but let's use it. Let's keep it for our reference. Click on create key pair. So it will download a file for you, which will be named as gitkey.pem. So that file will be downloaded for you. Then let the network setting be as it is. And we are going to create a new security group. So let this be the one that is being selected, create security group. So it will create a new security group for us. and the rest of the things will remain the same. Click on launch instance. So basically we are launching an Ubuntu instance. So once this instance is being launched, we are going to connect to this instance, and we will be installing Git on this particular instance. So now instance is running for us. We will connect to this particular instance. We will select the boxes over here and we will click on connect button. And once we click on connect button, we will then be clicking on connect. And once we are in, we will be following this particular guide in order to install our Git. So first we are going to update the packages. So let's say we update sudo apt update. So basically we need root permissions in order to update the packages on Ubuntu. So since this is running, once this gets executed, we are going to install Git by using this command sudo apt install Git. And since it is still running, let it be executed completely. Okay, so it completely ran and it upgraded 49 packages. That is what it said. Then we are going to run this command sudo apt install Git. This will install Git on our EC2 machine that we have just launched. So the Git is being installed, and we can check the version of the Git that is being installed by using the command git minus minus version. So it says that Git version 2.34.1 has been successfully installed. So what is the next step? Next step is we are going to integrate GitHub account with our Git account. So in order to do that, we are going to use this particular command. So let's say we are going to use git config minus minus global user dot name. Then you can give a particular user dot name, and similarly you can give a particular email ID, whichever you want. So let's paste these commands. Actually, the username will not be configured as of now once we are going to commit, and there is a reason for it. We will see about the reason in future, like how does it gets configured. We will look into the configuration soon. So to view the git config variables that we have just now entered, git config minus minus list, that is a command that we are going to use. So it showed us that these variables are being set globally. And then let's go to the repository that we are trying to clone. So what we can do is we can simply create a folder first, and inside that folder we will create a repository. Let's name the folder as Git Repo, and let's get into inside that particular folder. Once we are inside that particular folder, we are going to use the command git clone, and we are going to copy the link of that particular repository from the repository link itself. So let's say I'm going to clone this particular repository. So over here you can see that there is an option for HTTPS. So we will copy this particular link to this particular repository, and we will use the command git clone and paste the link that we just copied that was present in HTTPS. So it is cloning the repository that we just cloned. So let's see if the code is being cloned to our local repo or not. And for that, let's do ls. ls shows this project got checked out in our local, and once you go inside that particular folder spring boot h2 project, you can see that all these files are being checked out in our local. So that is how you clone the repository, and that is how you check out the files. Now let's say I want to make certain changes to my uh, readme file. So I will go and make the changes. So vi, so I'll be using vi editor, so that I have opened the vi editor, and let's go to the end of the file, and let's not make many changes. Let's add thank you for visiting, and let's save the changes. So we will use colon WQ and this exclamation mark and hit enter. So that means our changes are being saved. And if you want to see the changes, you can use the cat command to view the changes. So you can see that the changes are being saved, and the changes it says is thank you for visiting. So our changes are being saved. Let's check git status now. So git status is the command that will tell that what is happening, what is the current status of the code that we have checked in our local. So what changes are being made? So you can see that we have modified readme.md file, and it says that you have modified this particular file. And to update this particular file or to move your changes to GitHub, what you have to do is basically you have to add this file, and then you have to commit this particular file. And once you have committed this particular file, you have to push these changes to the GitHub repo. So let's say this is my GitHub repo. You have to finally push the changes to this particular GitHub repo. So how can you do that? So let's look into the tutorial. So finally, we are going to add the Git file, since it says that the file has been modified. So we can use the command git add for that. Git add, we can use the file name as well. And now let's check the status. So it will say that the file has been modified. So you can see that now the status has the color of the modified has changed from red to green. So that means we have the changes are now moved, are now being staged. And now what we have to do is we want to push these changes, we want to commit these changes, and then we want to push these changes to our repository. So basically, when we are doing git add, we are telling git that we want these changes which we are adding to the staging area to be included in the commit that we are going to do next. And they have to be the part of that commit. And if we are not adding certain files, so they will not be the part of commit that we are going to do now. So for committing the changes, we will use the command git commit minus m, and then we will get the message. So let's say we give the message first commit from Ubuntu, and it has to be a meaningful message so that next time when a developer looks into the code base and they want to identify that why these changes were being made, or they want to refer uh, to a particular issue for which this changes was being made, so in that case they can look into the comments that are being mentioned whenever you make the changes during your commits. So in one of my previous organizations, we used to add the ticket number, the ticket number that was Jira ticket number before the commit statement. So let's say my ticket number was SR100 colon. So this is how we used to add it before every commit, so that we are sure that okay, we are going to commit for this particular ticket. These were the changes that were committed as part of this particular commit that was being done. And after this, we are going to hit enter, git commit minus m, and then we are going to give the message, and then we are going to hit enter. So it says first commit from Ubuntu, one file change and two insertions. So basically it has committed the changes. Now we are supposed to push the changes. So git push origin in. So that is a command we are going to use in order to push our changes. So let's see what happens now. Our changes are going to be pushed or not. So it is asking for username. So let me give the username, and then it is asking for my GitHub repo password. It will not commit. It will not allow you to push the changes. The reason being, the password authentication was removed by GitHub on August of 13, 2021. And in order to commit our changes, in order to configure the changes, we have to do something. That is, we have to follow this GitHub authentication mechanism that has been defined. So basically we have to go to GitHub, we have to go to settings, and then we have to go to developer settings, and then we have to reach till personal access token classic, and finally we have to generate a token. And once the token is being generated, we are going to use this particular command in order to authenticate and in order to push our changes. So let's see, let's create a token, and we will do the authentication. So what you have to do is you have to go to your repo, and then you have to go to your settings, Once you are on your settings, you have to go to developer settings. Once you are on your developer settings, you have to click on personal access token. Let's click on tokens classic. So this was one of the tokens which I created earlier and it has expired now. So let's create a new token. So we will click on generate new token. Let's say generate new token classic. Classic is the one that we are going to generate. Let's give a note just for our remembrance and let's select the number of days we want this token to be expired. So we want this token to be expired on Wednesday 15 November 2023. So that way from the drop down you can select how much time you want this token to be expired. You can also make it custom expiry. So let's say you select for it for 1 day and then you are going to select the scope. You have to define for this particular personal access token. That means what all can be accomplished if someone has this particular token, what all rights are you going to give them. So let's say we are going to give them repo rights, we are going to give them audit rights, project rights, and let's say we generate the token. So once you click on generate token, you will be shown this particular token. You have to copy this token and you have to keep it safely somewhere. So let's say I keep it on a notepad. So you cannot use my token because I will be deleting the token after creating this particular video. So you have to create your own token. So basically, you can copy this particular token and you can keep it somewhere safe because you will not be able to see this token again. Okay, you also have an option to delete the token. So that is also a possibility that can be done. Now let's look into our tutorial which we were following. So now it says we need to use this particular URL in order to authenticate our repo by using the token that was given to us. So we are supposed to use this URL git remote my set minus URL origin, and then you have to give your token which was generated. So I'll paste the token that just got generated, and so I'm just creating my URL, the command that I need to run, and then you have to give your username. So you have to give the username of the repository that you are going to use. For me, it's Niagar, and then you have to give the repo that you're going to use. So let's say the repo that you're going to use is. Let's go back to the repository that we were referring to. Let's go to your repositories. Let's go to repositories. This is the repository that we have checked out. So let's say this is the repo that we have to keep with us and which we are going to add to the URL. So this is how the URL is constructed if you want to see. So basically git remote set minus URL origin and then https colon slash slash. You're going to give your token at github.com slash tech with Neha was my another GitHub repository and then slash the link of the repository. This is the username that you're going to give. So let's paste this particular token. Let's first clear the screen. So I have already created that token for us. So let's copy paste it here. So this is what we have created: git remote set minus URL origin https colon slash slash. Then I have given the token at github.com slash the username of your repo slash name of the repo that you want to be authenticated. Let's press enter. So this repo would have been authenticated. And now let's try running the git push origin command once again and see what happens. So now you can see that it actually started working on pushing the code changes to the repository, and it did not give us the error message that the repository, the changes could not be pushed in. Now let's refresh this repository and see if our changes are being reflecting here or not. So once I refresh this particular repository, we made the changes to readme.md file. So let's go down and see. Yes, so you can see our changes are reflecting over here and it says thank you for visiting. So this is what we added to our readme file. And one more thing, you can see that the commit that we did, that commit message appears over here. So it says first commit from Ubuntu. So that was the commit message that we gave. So this is basically how you commit and push your code changes, and this is how you authenticate your Git. So this is something really important which you should know, that how you can authenticate and you can allow an Ubuntu machine to push the changes to the relevant repository, or to the repository which you want the changes to be pushed. Let's say to your repository only, because you can generate token for your repository only, and you have to keep that token safe. So I have shown you how you can do that. Also, you can follow this particular tutorial if you want to know a few more commands. Like you can learn about viewing the branches, you can learn about how to create a new branches. So let's look into it. Let's see how you can uh, view the branches. So let's give the command git branch minus a. So this command will show us that these are the branches that are present, and asterisk main means that this is the branch where we are currently. So next command that we can look into is git checkout minus p develop. So this is the new branch that a developer can create and they can start working on that particular branch. So let's say git checkout minus b develops. So develop is the branch name that will be created. So a new branch named develop has been created. Now let's run the command git branch minus a and check. So you can see that our pointer has changed. It says asterisk develop. Now we are on this particular branch, develop branch. So that is how you check out a new branch, and that is how you check the list of branches that are being present. And you can also switch the branches by using the command git checkout. So now let's say we want to go back to our main branch. So you can use the command git checkout main in order to move back to your main branch. And now if you run the command git branch minus a, you can see that you have changed your branch to main branch. So that's it for today. I hope you enjoyed today's video and the tutorial. And if it was helpful for you, please give it a thumbs up and please subscribe to my channel. Also, we will be sharing more interesting Git and GitHub projects in the future. So I'll be sharing a lot of different commands, good commands such as merge and different other commands, which are quite useful for your journey as in DevOps journey, as well as a developer as well. So thank you. Bye bye.